1.7 Linear Inequalities Preparation. Okay, so now we're going to do intersections of sets. Go right here. This kind of shows you the and or intersection of two different sets. So you have set A right here, right? Then you have set B, right? And the part where they intersect is where the elements of both are, right there in the middle, okay? So for instance, let's say we have a set that's 1, 2, 3, 4, and then we have a set B that's 2, 4, 6. So we would want to know where they intersect. So for instance, let's say, you have your 1 there, you have your 2 there, you have your, let me show what this looks graphically. Okay, so let's say you have 1 there, 6 there, you have 2, and you have 4, like that, right? So, and you also have a 3. So you have 1, 2, 3, 4 over here. 1, see, we have 1, 2, 3, 4, right? And that's an A. And then over here on B, we have 2, 4, 6. So we have 2, 4, 6. And the part that we're interested in, whenever we have this little symbol here, which is the intersection symbol, or the and symbol, is where they overlap. And graphically, you can see the 2 and the 4 overlap, right? So we would simply say that is equal to, and you can do another little set notation, is simply 2 and the 4, because that's the part that overlaps, or the parts that's the same in both, right? This 2 here, this 2 here, this 4 here, this 4 here, and that's where they overlap. Okay, so how would we apply that to inequalities? Well, first, we would graph each inequality separately. So let's see that. So for instance, let's say we want to do x plus 1 is less than or equal to 9. So, minus 1, cancel, cancel, x is less than or equal to 8. So we would, there's 8. And since x is less than or equal to 8, we know it's opening to the left. And because it has the equal part, we know it's a bracket. So I just follow that, right? Okay. So now we solve the second one, right? Whenever we solve the second one, so now we have x minus 2 is greater than or equal to 3. So plus 2, cancel, cancel, x is greater than or equal to 5. So we plot the 5 right here. But because x is greater than or equal to 5, we know we're going to have a bracket, and because x is greater, that's going to be to the right. And because the arrow is pointing to the right, we also know it's going to open to the right. And then it's this part right here. Now, the part that we are interested in is the part that overlaps, right? So the part that's the same for both will be right there. Okay, so solve the compound inequality and graph the solution set. So we are going to include the whole thing from 5 to 8, and we have a bracket on both because we include both. Okay, let's try this again. So again, we're going to solve both of the inequalities separately, graph them separately, and then we're going to be interested, because we're dealing with the and, we are going to be interested where they overlap. Okay, so we're going to try to get this negative 3x out of the way by adding 2, cancel, cancel. Negative 3x is greater than 7, divide by negative 3, divide by negative 3, cancel, cancel. X is, oops, there we go. It's going to be a 7 divided by a negative 3, so it's going to be 7, negative 7/3. Let's try the other one. Same. Well, let's finish graphing. Okay. So we have a negative 7/3. That's the same as negative 2 1/3. So negative 2 1/3 be right about there. This says that it's going to be x is greater than. Okay, but there's a little bit of a stickler little thing in here, right? Okay, so what we're going to do here is that because we divide both by a negative, we can't have greater than anymore. Now it flips to less than. So now it is less than, because we divided both by a negative 3. We had to flip the inequality symbol. Okay. Okay. So now x is less than negative 7/3, or less than negative 2 1/3. So since it's less than is to the left, less than left. And because the arrow is pointing towards the left, we also know it's going to open up towards the left. Now, because it doesn't have the equal part, we are going to use the parentheses. Okay, so let's do the same procedure again, but this time we are going to do the other ones. Okay, so we have x, 5x minus 1 is less than or equal to negative 21. We get rid of the negative 1 by adding 1. What if we do one side, we do together, cancel, cancel. We have 5x is less than or equal to negative 20. Then we undo the multiplication by dividing by 5. What if we do one side, we do together. These cancel out. That gives me x is less than or equal to negative 4. And what we do is we graph the negative 4. We plot it right here, negative 4. And because it's less than, x is less than or equal, we know it's going to open up to the left. Less is to the left. And because it has the equal part, we are going to use a bracket. Okay, and we shade it in. We shade all that in. Okay. Now, because we're dealing with the and, we're interested in where they overlap. And where they overlap is right here, right? They overlap all there. That's where they overlap. In fact, they overlap all the way to the bracket, right? Okay, so we are going to rewrite that. Now, remember, over here to the left, if it keeps going forever, that's a negative infinity. So if we were to write the interval notation, we'd say it's negative infinity all the way up to negative 4 bracket, right? Now, all the way to that negative 2 1/3, that's by itself, so we don't include that, right? We only include the part that overlaps or that's the same for both. All right, let's try another one. We'll do them separately again. Okay, so we're going to graph these separately. X plus 2 is less than 5, minus 2, minus 2, cancel, cancel. X is less than 3. So we're going to plot the 3. And we say x is less than 3. So we have an inequality like that. Because this is just less than and not less than or equal, we have the bracket opening up towards the left. So we just shade all that in. Okay. And over here, now since we finished solving that one, we solved the other one. Notice that we completely solved them separately. We solve it separately, we graph it separately, and then it's only in the end that the interpretation changes, depending on whether it's an intersection and, or whether it is a union, which we're about to do, or. Okay, so the only interpretation at the end changes at this point. Okay, so we x minus 10, we undo the subtraction 10 by adding 10. Whatever we do one side, we do the other. We end up with x is greater than 12. And 12 is over here somewhere. Okay, now x is greater than 12, so we know it's going to open up towards the right, and because it's the inequality, you know we'll be shading this in, right? And that goes off to positive infinity. And here is the thing, though, right? Theoretically, I mean, there should be something overlapping, right? And you notice that none of the red overlaps with any of the blue, so there's nothing. Yeah, there's no overlap. So there is no solution to that. And that's that.